Good afternoon. We would like to present what we have done in developing Gena, a cross-domain crowdsensing infrastructure. The crowdsourcing citizen science paradigm is an innovative paradigm where some activities are moved outside the scope of research institutions toward external volunteers. There are some enabled technologies in this, such as IoT, open access to online maps or mobile devices. There are constants in this. Of course, data must be georeferenced, and there must be some kind of wireless transmission of data in real time. Since there are many platforms acquiring data at the same time, data is redundant, and there's a large quantity of data arriving at the same time. So these often stress technologies, and so my infrastructure must be robust, reliable, and resilient. Privacy can be a concern because even positioning can be sensible data, and the quality control is also a concern. The main advantages, following many authors, is mainly economical and logistic. But I would like to stress also that crowdsourcing is a way to improve spatial and temporal coverage. The main issue is related to quality of data. So crowd data can be as good as those from authoritative sources, following several authors, but indeed low-cost sensor can create some issues in accuracy and precision, which needs some validation. Plus, the volunteers' expertise also needs sometimes training. There is an increase in the number of platforms, which means rises in cost. There can be difficulties in planning the acquisitions, which is sometimes good to avoid researchers' bias. Sometimes this is a problem because you have to convince volunteers to go to specific areas. The Gena workflow is pretty simple. So multiple platforms are provided with boxes that contains GPS and the sensors. Data is transmitted, received, stored, and validated, and eventually it is accessible through web maps or other forms of web data access. We have developed also many projects on top of the Gena infrastructure, such as the MedCrow project. Please attend poster presentation number 62. Within the MedCrow project, we have developed a case that holds the electronics and the sensor, pH, salinity, temperature, and dissolved oxygen. This case can be attached to any boat, a leisure boat, and it can send the data, which eventually can be represented, for example, in a map such as this that you can see in this presentation. Another project built on top of Gena is Cocal, where we developed boxes containing sensors for air quality. And of course, these boxes can be attached to a car in urban areas or to a boat at sea, so we can join information from both environments. NoiseUp is another initiative built on top of Gena that is based on a mobile phone app to monitor noise pollution in urban areas. So there are already existing solutions similar to NoiseUp, but this is fully integrated in Gena. Quality control is another problem we already mentioned. We tackled the issue at two levels, using statistics of the redundant data to address electronics issues or spikes or improper use of the sensors, while we use the reference values from for example, environmental agencies to address problems with sensor drift and issue in deployment of the sensors themselves. I would like to show you the improvement in coverage and resolution we can have applying the crowdsourcing paradigm. On the left, we have the 4 active stations of air quality monitoring of the environmental agency in our city. Of course, the resolution is very low, while we can have the map coming from the Gena infrastructure with a resolution of 200 meters by 200 meters by 1 hour. Conclusions: we have developed a full infrastructure that can be used by crowdsensing citizen science initiatives. This infrastructure covers all the aspects from data acquisition to web data access. We have tackled the issues of quality control using statistics on the redundant data and the reference station from an environmental agency, for example. Acquisition hardware is low cost, so it can be provided to volunteer citizen science without too many concerns. And we have fostered so far several citizen science initiatives such as MathCrow, Kokana, and NoiseUp, and we hope many more will come. Thank you very much for your attention, and please do not hesitate to contact us for any question.